right, good morning, everybody. Thanks for joining us for our NUIT Tech Talk on visualization services on visualizing data at Northwestern University. I'm Christina Bello with the NUIT Communications team and have with me today's presenter, Matt McCrory. Before we begin the presentation today, if you're having any trouble hearing me or Matt, please make sure your volume's adjusted accordingly. Speakers are turned all the way up. If you're using headphones, those are connected. Also, make sure that you're using a wired internet connection if that's available, and that you close any applications running in the background that are connected to the internet, including email, any other web browsers you might have open. We're going to do a lot of screen sharing and demonstration during the presentation today with some video, so that'll just really give you the best connection during the presentation that Matt's going to go through. If you have a question at any time, you can type it into the Q&A box down here, and we'll answer those questions throughout the presentation. After the presentation, we'll also give you an opportunity to download a version of the PowerPoint that Matt's going to go through. We're also recording this, so you can watch it at a later date, and we'll probably post that today or tomorrow. And that should be all the logistics. We have a couple quick poll questions we just want to get your sense on here. So our first question is, what school or department are you in? We're just kind of curious what who our audience is today. So you can type your answer in here and submit that, and we'll see who we've got in the audience today. Okay. McCormick, Medill, Feinberg, several Feinberg people. Great. Okay, I'll give you all one more moment to answer that question. A couple alumni relations folks. Great. Okay, and we'll move on to the second question, which is here. Are you familiar with Northwestern Visualization Services? Have you heard about it before? If you use the services, and if I'll add another part to this, if you are familiar with services, if you want to just type into the Q&A box and you've heard about the services or how you're familiar with the visualization at Northwestern, just type that into the Q&A box. We're just kind of getting a sense of how people have heard about these services so far. But it looks like a good majority, this is new to you. So that's also good to see. You'll learn something new today.
Yeah.
Okay, great. All right. So with that all said, I will hand it over to Matt.
All right. Thank you, Christina. I'm going to speak a little bit about the visualization group at Northwestern and basically just tell you about what we do. Tell you a little bit more about myself to start out. So I'm the lead visualization engineer at Northwestern. My background is kind of a mix of both entertainment and research. So I actually joined Northwestern about close to 7 years ago now. But when I joined, I had previously been working at DreamWorks Animation for about 4 years. Before that, I was at University of Chicago as well as Argonne National Lab. So I have a mix of both research and entertainment-driven visualizations. And here's sort of a visual snapshot of some of the work that I've done in the past. On the upper left there, you see stuff that's more sort of research-driven. And on the upper right, this is more of my entertainment-driven visualization. Some of you may have seen some of the movies here. So this just gives you a quick idea of the world that I've kind of come from. So to start, I want to get into just the basic question of what is visualization. And to give the most basic explanation I can, basically I've come up with this. It's basically the process where you start with data, you apply some sort of work, and in the end you end up with imagery. And to make even this definition visual, as an example, here we have a data set that's a file that was generated from a simulation that was run on Quest. And in this simulation, the evolution of the binary star system was what was being simulated. So the end result was a bunch of numbers, kind of a spreadsheet-looking file with a bunch of rows and columns. And so the rows are each time steps in this simulation. The columns are all just properties of the stars. And so that includes things like mass, radius, temperature, things like that. And so then on the right, we produced an animation with this. And so that gray arrow in the middle is kind of where all of our work falls. So back to this definition. I want to talk a little bit more about both the kinds of data that we can visualize and the different forms of imagery that we can generate. So on the data side, we've worked with a lot of different kinds of data, and I've started just telling people that we haven't really encountered a data type yet that we haven't been able to visualize. So don't worry if you're working with something that seems really obscure and not very standard in terms of the type of data you're using. We can probably find a way to visualize it. But in the past, we've worked with n-body simulations. We've worked with hierarchical files like HDF5. We've done a lot of visualization of protein crystal structures, which generally start as PDB files. Imaging Z-stacks are something we've volume rendered quite frequently. And then just general OBJ 3D files. And then big data is a new kind of hot thing that we're starting to get more and more into. And so all of this is kind of what we start with. And then in terms of what we can generate from it, it's typically something that falls into one of these three categories: interactive visualizations, illustrations, or animations. And so I'm going to talk a little bit more in depth about each of these three categories. I've ordered them kind of in the same order that you might find that you need them through this sort of normal research pipeline. So typically you might start by needing interactive visualizations, and then later on when you've made discoveries and you've got something you need to communicate, that's when you typically might need an illustration or an animation. So I'll get more into that in a second here. But I do want to add as one final data type that we work with, just simply ideas. So we don't always need to have data that's in the form of something, you know, in a file or something like that. If you simply have an idea of a mechanism that might be at work that hasn't yet been measured, and you need something to illustrate that, or maybe an animation that shows that, that's something else that we can do.
And I'll just mention that, kind of comment on that with some of the information we talked about here. I know we talked a little bit when we were preparing for this that, you know, a lot of people think visualization would just be sciences or engineering or, you know, some of the topics you talked about earlier, but it really can be anything. So I know we had a lot of alumni relations folks mention that from that department. So it really can apply to any area. Yeah,
and I mean we're involved with some interesting new project ideas now, even with the humanities, with the drama and theater. Mm-hmm. So really, there's no department or school that we can't work with, and we're actually excited about working with as many different schools as we can.
Cool.
So with that being said, I'm going to talk first about interactive visualizations, which I think typically are kind of thought of as the more sort of traditional scientific visualization. And this is, again, where you might start in the scientific process with visualization. So this is where you have a chance to explore your data. You can interrogate it. You can make discoveries within it. And you can quantify it. So a lot of times you want to measure the data that you're actually looking at. And so this interactive visualization can be seen on a number of different platforms. And so the platform that you're viewing right now in that video is basically just a native application. And this is one of the things that we can produce. So native applications, they run locally. So you use your local computer, and you're sort of, in a way, you're limited, I guess, in that sense, because you know, your computer's only so powerful. So same with data, you kind of have local data. So the sort of result of that is that you have some amount of portability, but you don't have a ton of portability. You could put an application like this on your laptop along with all your data, and you could bring that around, but it's not as portable as some of the other platforms that I'm going to talk about. So advanced displays is something else that we focus on in our group. So what you're seeing in the video here is the 3D visualization wall in the Center for Advanced Molecular Imaging. And what we have here is something with massive resolution. So we have almost 52 million pixels on this screen. We also have something that's 3D. So we have stereoscopic 3D. We're wearing 3D glasses. Because of this, because of the size and both the 3D effect, it becomes an immersive environment where you feel like you're actually walking within the data. And it's very collaborative in that we can have 30 or more people actually all in that room wearing 3D glasses at the same time. It's not as mobile, but if you're collaborating with people who are local, it's a great device to work with. So we're also getting more and more now into web apps where people can use their web browser to do some of the visualization work for them, and basically, you know, kind of tap into data that might be on a server somewhere. The great thing about web apps is that they're platform agnostic. So as long as you're using a browser that conforms to the various web standards, you could be on a PC or you could be on a Mac or on Linux. It's all going to work. So it's very shareable as well. It's a matter of just simply sending a link to someone, really, in most cases. And that also makes it fairly mobile as well. And one of the areas that actually we're really excited about now is this idea of cloud rendering. And I'm sure many of you have heard of cloud computing. And before I go too much further, I just wanted to put this up and just let everyone know that despite popular belief, storms do not affect cloud computing. So don't worry about that. But if you're familiar with cloud computing, you know that basically you're sort of using a remote facility that has a bunch of high-powered servers to crunch through numbers for you. And then at the end, they produce some data that you'll need to kind of copy back and figure out a way to interrogate, maybe visualize. So with cloud rendering, we now have a way of doing the visualization remotely in addition to doing the computing remotely. So just to kind of illustrate this, we have a series of servers somewhere off at a remote site, crunching away, coming up with your data, and then we're able to send the resulting images down to any device that's capable of decoding an H.264 video stream, which is essentially like what YouTube uses. So if you can watch YouTube on a device, you should be able to use it to do cloud rendering. So what's great about this is you sort of centralize everything. You have the GPU, all your graphics power, all of your CPU compute power, and all your data co-located in the same place. It's all in that same remote resource. So you've centralized everything. This is also platform agnostic, again, because you're just using a device that can decode video. It could be PC, it could be Mac, it could be Linux, and it could be tablets and phones and things like that as well. So that also makes it very portable. It's collaborative as well in that if you're viewing something, you can have other people kind of all paste the same URL and all see the same thing that's being visualized, and then they can actually add their own input and manipulate the same object. So it's collaborative across a very broad area.
I'm just curious, can you give an example of one of the visualizations you've done that's been interactive like this?
I'm actually going to give a demo of that in just a minute here, so you'll all actually be able to see it.
Great.
Just a couple more points. This allows us to centralize the app development as well. So instead of everyone having a separate device and everyone has their own version of a piece of software and maybe they're not all in sync, we can do all the development on one application that resides, again, in the cloud. So anytime you log in and use it, you're going to get the most up-to-date, most bug-fixed version of the software. And the other great thing is that you can view just massive data sets on really low-power devices that otherwise would have no chance of being able to actually visualize these things. So, that being said, it's demo time. So I'm going to show you. This is a web browser. This is just Firefox. And so what we're seeing right here is actually a data set from the Sierra group in astronomy. And this file is about 1.5 gigabytes in size. I can zoom out, and I don't know how well this is coming across on stream, but I can zoom out quite far, and there's basically kind of a whole universe full of points here. And this data set is representing simulation, one time slice out of a simulation of galaxy formation within the universe. So there's actually a lot of galaxies that are forming here. And so we just see millions and millions of particles here. And so it's something that, again, it's not running locally on my machine. This is actually running on a computer that's in Silverman Hall right now. But I can interact with it almost as though it were a local native application.
Very cool.
So, and this actually, we've also tested this on our phones as well. So,
nice.
As I'm interacting with this, if other people are, at this URL, even from a tablet or a phone, they'll see exactly what I'm doing and get the same visualization. So, yeah, and then at this point, this is really just a proof of concept. We have a few basic sliders for adjusting some of what you're seeing here, some of the different values that are in this massive file. But eventually, you can imagine that we'll have fully featured user interfaces and things like that to really make this fully functional. So that's the demo of cloud rendering. And I'm going to return now to talk a little bit about the tools involved with developing these interactive visualizations.
Great.
So for workstation apps, for those native apps, a lot of what we've done is develop stuff in C, C++, and Python. And when we use those, we typically are also using something like OpenGL, the graphics library. But there are also these off-the-shelf products that I'm sure many of you have heard of, like MATLAB R, Matplotlib, BTK, ParaView, Visit. They are great for visualizing a lot of very commonly used data sets. So those are options that people have if they're looking to do just workstation local visualizations. And then for advanced displays like the 3D wall, it's a lot of the same like C and C++ and OpenGL, and then additional customized software as well, like TCP/IP for doing networking. We had to build a little bit of a frame.
Sorry. Okay, there we are. We're back. Okay, sorry about that. We just lost the audio for 1 second.
Oh, okay. Do you know how long?
Just for about 15 seconds. So if you just want to go back to the bullet point right before.
Sure. So for advanced displays, like the 3D wall, we're doing a lot of our own custom software for that, and we use C and C++ and OpenGL. And we also use a lot of TCP/IP sockets, really kind of lower level networking stuff. But then we also have to do some frame locking to make sure that all the displays are in sync as they display something, so it looks as though they're all operating like one continuous screen. And then we have a tiling framework that we've developed as well to make it easier to write code that is just automatically sliced and diced to go on each of the 25 screens. So for web app development, there are some tools out there like D3.js that are actually pretty easy to pick up. So if you're curious just about how to do some basic information visualization, I recommend just Googling D3.js. And they have a lot of examples, so it's easy to kind of, cut and paste your data and replace some of their data. But then in addition to that, there's HTML5, there's WebGL, there's IPython. All these are really increasing what we're able to do all within a web browser. And for cloud rendering, this is a very new area, as I was saying before, but so a lot of the same development that we might do on a workstation, or a lot of the same tools we might use on a workstation, we can use for cloud rendering as well. And that means custom software as well as, by using virtual machines, we could potentially run some of that off-the-shelf software as well. And so this is just a real brief, touching on all these things, but on June 3rd, we're going to have a toolkit actually where we talk a little bit more about these things. And the person who is going to be giving this particular toolkit is our Senior Interactive Visualization Specialist, right here, Alessandro Cabretti. So Alessandro is one of the newest members of our team, and he's working on finishing up a PhD at UIC's Electronic Visualization Lab. In the past, he's been a software engineer on video games at Milestone Games. He's developed software frameworks for some of those advanced displays, including Cape 2. And he's basically got a lot of experience developing interactive applications on all of the platforms that I just described. So native apps, web-based, advanced, and cloud-based. So here's kind of a visual snapshot of some of Alessandro's past work. On the upper right, you can see the Electronic Visualization Lab and Cape 2, which is, in a sense, kind of like the holodeck on Star Trek, where you kind of walk inside and you're surrounded by 3D imagery. It's almost like you're walking into a whole different world. And then you can see some of the video game work that he's done as well. So there's kind of this theme here of we're kind of bringing a bit of industry experience and know-how to academia.
That's great.
So once you move past the stage of your research where you're doing interactive kinds of visualization, at some point you'll have discoveries that you need to communicate and you need to disseminate. And so for doing that, illustration and animation are two very effective tools. And illustration, as I say here, it conveys scientific understanding in a way that words alone cannot. Mm-hmm. And so a lot of the work we've done recently in terms of illustration has been producing artwork for journal covers that really, communicate the discovery that a researcher may have made. Right. And they do it in a very aesthetically pleasing kind of way. So all three of these here are examples of covers that were produced. Occasionally we have covers that we generate the artwork for, but they just don't get chosen for whatever reason. But in the end, we still have really beautiful pieces that researchers are then able to add to their media that they can take with them when they present and submit for different things.
So this is pretty much the saying, a picture is worth 1,000 words.
Exactly.
Exactly.
Yeah, that's it. Yeah, and with research, it might even be more than 1,000 words. Yes. So, but we also do illustration that's not, geared as much towards something artistic and cover oriented. Sometimes we create illustrations that are more helpful for a researcher's presentation or a document that maybe they're putting together. It could be a grant proposal or something like that. And so we can put together just kind of these simpler, smaller scale things as well. Great. Which is just something to keep in mind. So animation is kind of the next progression of illustration, where with illustration we have a static image. Animation is a series of images that plays in sequence, and it helps us understand and depict the progression of data over time. And the movie that's playing right now is kind of a good example of this, when we have an n-body simulation that we started with. That's sort of the data side, and then the visualization side is an animation where we have a bunch of stars and black holes in a star cluster that are all sort of orbiting each other. And the stars are very obvious, but then the black holes you really can only detect because of the gravitational lensing effect that they're having on the stars. So you see all the light kind of warping around these different points that are animating throughout this scene. And those are the black holes, and it's kind of, what you would observe if you were to actually look for this sort of thing. But I'm going to spend more of the time on animation actually just talking about the animation pipeline, which is simply the set of processes and tools that are needed to take an animation from concept to the final product. I think animation is one of those things that oftentimes needs a bit of a demystifying because it's sort of like this mysterious black box where, we take your data and then we kind of generate something and you get this nice, pretty animation. But there's actually just a ton of different steps involved and a lot of work in each one of these different stages. And so as kind of a case study here, I have an animation that we produced where we have a virus that is going to fuse with a healthy cell. And so the virus is on the bottom here and the healthy cell is on the top. And there are these different mechanisms at work and a number of different kinds of data all represented within this animation. Some of it is actual data that was captured from molecular dynamics simulation. Okay. And some of it was animated to sort of look like that same sort of, simulated motion. So, and you can see here that there's some different things going on visually. We have sort of a space-filling representation of some of these molecules, but then for kind of our star protein here, some of that fades away and becomes translucent, so we can see a ribbon representation of the underlying structure. And so at the end here, the cell membranes fuse together, and that's our animation. And so we actually have this animation as well as a couple others from different perspectives, which is one of the advantages of doing digital animation. So anyway, this is sort of actually it's kind of a truncated version of a typical animation pipeline, but we have to kind of keep it short. So, so I'm going to talk a little bit about each of these different stages. We start with a pre-production phase and we go into a production phase. So starting with data and asset assembly, this is where we take some of your data and we really start to investigate how are we going to be able to take the data and bring it into our artist tools and work with it. And so you can see this text file here is actually just a piece of a PDB file where we just have line after line representing different atoms within a molecule and the Cartesian coordinates for each of those atoms. And then this is kind of a visual representation of some of that, where you can see these proteins as they're at different stages of folding. And so these are kind of our points of reference when we work on a project like this. So not all the in-between forms are there, but that's kind of where we can fill in and interpolate a bit. So I also wanted to just play this. This is actually VMD, a molecular dynamics and PDB visualization tool. And this is playing through some of the dynamics simulation that we've worked with. But as you can see, this molecule is kind of floating around. It's not really anchored to anything. And so that's just sort of representative of one of the sort of little challenges that we deal with as we work on a project like this. And I'll talk a little bit more about that in a second. But the next thing we generally produce is sort of the equivalent of a storyboard, only these days studios use storyboards less and less as it becomes easier to put together this sort of pre-visualization, which we also refer to as an animatic. And it's just a very rough, usually kind of grayscale approach to, this is sort of our broadest stroke. This is what the animation is probably going to look like. And so in addition to this, we will sort of start to work on some art keys to establish a visual direction for the piece. So this is usually just like a frame or two that we've painted over to set a target of this is what we would like to achieve by the end. And we don't always get there. It kind of depends on things like budget and other things. Right. This is sort of like in the ideal world, we would produce something that looks like this. So now moving into the production phase, you start typically around the modeling and rigging stage. And this is where the actual objects themselves are being put together. You're actually modeling these things that we're later going to be animating. Rigging is a process of giving sort of a skeleton to these objects. So without having some joints and rigid parts that they can kind of conform to, you don't really have a good way of moving these things around, which you have to be able to do for animation. So in animation, there's actually a whole lot of other short video clips that our senior animation specialist included in his recent toolkit, but I'm only going to have a few of them up here. But you can get an idea of a lot of the sort of in-between stages that have to be developed. In the upper left, you can see again that sort of floating simulation, and it's sort of sitting side by side with the stabilized version of that that we're then able to bind to the surface of the cell and actually animate the way we want to. So all sorts of little animation procedures have to sort of occur in this stage before we can get to the next stage, which is surfacing and lighting. And with surfacing, you can think of this in the same way that when you interact with surfaces in the real world, every surface of every object reflects light differently, it transmits light differently, in some cases it emits light differently. And so we have to simulate the same thing in our sort of virtual world. And what you see on the right there is some tests of the subsurface scattering shaders that were applied to some of the surfaces of the molecules. Subsurface scattering refers to the sort of translucent effect that you see on the edges there, and that's caused by light that enters an object in one area and then bounces around a bit internally and then exits in another area. And so you see this kind of like with your skin and stuff. And then once you have surfacing shaders and things like that, then you need to also start putting together a lighting rig where you sort of direct people's eyes to certain parts of the scene just simply using light and color and things like that. And so once you have that, you're ready to actually start rendering out frames. And once you start rendering out frames, you don't actually render each frame in completion. You're actually rendering out parts of each frame. So you end up with a series of different parts of each frame, and then you have to sort of assemble them. And that's what compositing is. You're taking each of these parts of a frame, putting them together, and applying filters that help kind of achieve the final visual look of the animation. So in this little video here, there's kind of a step-by-step of each of the layers being composited together. It's mostly, in this case, different lighting layers. We do have an object layer that gets added where we'll see the underlying ribbon structure in a second here. There it is.
And Matt, while we're watching this, somebody had a great question. How much is the researcher involved in any one of these steps?
Yeah, well, that's a great question. And actually, I was going to address it in a little bit. But I can say right now that we work very closely with the researchers. We iterate, constantly with them to make sure that we're not straying in any way from their science, that we're not misrepresenting their data in any way. So there's this constant consultation that's going on.
Great.
So that is sort of the 3D animation pipeline, at least a very basic, in a nutshell version of it. But in addition to this kind of animation, there's also 2D motion graphics, which we can also do. And 2D motion graphics are great for presenting information in a clean and non-complex visual style. And so I've got a short little example of this. What you're seeing on the right is actually 4 short videos that I've concatenated. And you can see it's very simple, it's 2-dimensional, and it's sort of like a moving illustration that you would see sketched out on paper. And in this case, we're looking at movies that were assembled into a presentation, a slideshow for one of the math faculty members here. And in the end, we ended up with almost 200 of these short videos that each took up 1 slide, and they just sort of automatically played for each slide. So nice. It was like she kind of was able to walk through this motion graphic animation. Perfect. So
yeah. So I would imagine like a graphic like that for kind of classes, for students, that's a great option.
Yeah. It's great for educating and communicating, especially if it's a complex idea that you can break down into something simpler. So yeah, it's definitely a great tool to have. So, and speaking of tools, here are some of the tools that we use. For a lot of our 3D work, we rely pretty heavily on Maya, which is software produced by Autodesk. Maya is great for doing almost the entire animation pipeline for 3D animation. So, we do modeling, rigging, animation, lighting, surfacing, pretty much everything, even down to some of our rendering in Maya. There are some other renderers that we use, and in those cases we might have to do something different for the surfacing and lighting stages. But Maya is a great sort of all-around Swiss Army knife kind of tool. And then for compositing, I showed you a screenshot earlier, that was NUIT, and that's just a fantastic tool for bringing together all the different elements of a frame and building up that final visual polish. And then for some of the motion graphic stuff, like the animations that I just showed you, I use Adobe After Effects for stuff like that. And actually, the 3 links here for each of those tools, those should link to either a student version or for After Effects. I think we have our own sort of site license. And if you're not able to access the site license, I think we can at least get like a $5 a year kind of membership or something like that. And
we'll have all of this available in the PowerPoint that you can download after the presentation.
Right. So, and then I just have one tutorials link. I meant to add some more, but if you'd like to learn more about this, just don't hesitate to contact us and we'll send you some more. But molecularmovies.org is kind of a great starting point for anyone interested in doing scientific visualization or scientific animation, I should say. It's a site that offers a gallery of movies that have been put together, but also gives a bunch of tutorials on how to use Maya, how to use After Effects, and some of these other tools. So Justin MUIR is our senior animation specialist. So over the last 2 years, he's basically been our go-to person for all the animation work. He put together that fantastic virus animation that I showed, as well as the black hole and star and body animation, as well as a bunch of other ones. But he joined us about 2 years ago after about 20 years of working in the gaming industry. And he was an art manager at Day One Studios, working on games like Silent Scope and Fear 3. He was a director of animation at Midway Games, and he's basically an all-around expert in digital animation tools. He was using Maya since version 1.0, so he's become very familiar, especially with that particular tool. But here's sort of a visual snapshot for him, some of his past work, so we can see a little bit of the world that he came from. Obviously, again, it's very entertainment driven, but that's a world that teaches you a whole lot in terms of developing an eye for aesthetics and for the arts, and for just getting to really know how to produce something. But from there, now he's moved on to stuff like this, and it's just, he's been able to generate some fantastic work. The animations there were just recently featured on WGN, actually, among a bunch of other places, science sites and things like that. It's research from Teresa Woodruff and Tom O'Halloran, where they made a discovery related to the zinc spark that occurs when an egg cell is fertilized. And then besides those animations, you see some art keys here that Justin put together, as well as one of the illustrations. So just really beautiful work. So next, I want to just talk a little bit about how to work with us and what kinds of things we can help you with. Certainly, general questions should be sent our way. If you're just wondering, if there's visualization software already that does the thing that you need, maybe it's something that you think is pretty basic. There's a good chance that there's something out there that we can recommend that will help you with that.
Great.
So we'll do our best to steer you in the right direction for that. And then if there's something that's a little bit larger scale and you need to sort of determine how complex it is, what it's going to cost, things like that, we can provide that guidance. One thing that we've encountered a few times is that sometimes researchers don't realize how quickly and efficiently we can put together a visualization, because to someone else it might seem like it takes a lot of effort. But definitely check with us first and see what we have to say about it. That's a
great point to add, and I'll add as well. Again, kind of the visualizing data. A lot of people automatically think sciences, medical stuff, but as you said earlier, this covers pretty much any topic you can think of. Humanities, as you mentioned, and stuff like that as well.
Yeah. So anything, and like I said, it could be data-driven or it could be just simply idea-driven as well. So, and then a lot of that guidance can be used for things like grant proposal input, where maybe you're trying to determine what the visualization component of your research is going to cost. So, and so typically the way getting in touch with us works is we start with just requesting a consultation, which you can do at our website, which is pretty easy to remember. It's just visualization.northwestern.edu, and there's a link in there to request a consultation. And so it's at that first meeting where we really start to try to understand your science and understand what you're looking to do from a visualization perspective. And based on what we find out there, we can determine, as I said, if there are existing solutions out there. And if there are, we will steer you in that direction, because we certainly do our best to avoid reinventing the wheel. So it turns out that there really isn't an existing solution. Maybe it's just a little bit more complex. Then we'll begin a preliminary investigation. And at this point, this is where we start putting together some previs, some animatics, like what I showed with the virus movie, where you saw that sort of gray animated storyboard.
Right.
And proof of concept code as well, which would include the demonstration I gave of the cloud rendering. That was actually all this proof of concept code. So this is something that we developed for the Sierra researcher. So this is before we've even agreed to anything.
Yeah.
So, but at a certain point, we are able to use that investigation to determine how much work is going to be required for us to actually get you what you need. And so we'll generate a quote. We'll go over it, adjust it as needed. Our recharge rate is $60 an hour, but I have to add the caveat that the amount of hours required for any given project varies quite a bit. So there are some projects that we can finish pretty quickly, and other ones that are really complicated are going to take a little while. So,
and is there any charge for the consultation part?
No, everything is free. Until we get to a point where you give us kind of the green light after getting the quote. So, I mean, we do a good amount of work. I mean, we put in a couple solid weeks of work just to develop some proof of concept code or some pre-animations. And at that point, we kind of determine if it's in your budget to move forward. So, assuming we get the green light, then that's when we start to iterate with the researcher until completion. And this is where I was going to, again, emphasize that we work very closely with the researchers and iterate very frequently to make sure that we're staying on target.
Great.
And so that's pretty much it. I want to thank my staff, Justin and Alessandro, as well as my student staff, Brad and Michael, and thank you, Christina, for hosting this.
Yeah,
and don't forget about the Researchers Toolkit series. It's June 3rd, and I think the last time I checked, there were like 11 spots open.
Okay.
So if you are interested in attending that, you should probably check out that link pretty quick. Yeah.
And then we'll leave it open for questions. We have a couple more minutes, and we actually have some poll questions as well before we wrap up. And I will just mention again, we have the PowerPoint available for download. If you stick around for a couple minutes, we'll have that available at the end. And we are recording this, so we'll be posting this later today or tomorrow. You can download or view that as well. We'll be sending out a link to that recording. So I'll just open it up for any questions. You can type them in at the bottom of the screen as we kind of go through the last couple poll questions here for you. All right. So our 3 quick feedback questions are, do you plan to apply any of the information you learned at today's event, even if that's just contacting Justin and his team for a consultation and trying to see what of your data can be visualized, what works for your area. Again, I know we had a lot of different people from a lot of different departments on the presentation today, so student affairs, fine bird, statistics, some engineering folks, just pretty much all over the university. So, and if you're unsure about how to apply, that's also a great question that could be directed to Matt and his team. Yeah, if you have any questions about how to apply what Matt went through, do feel free to contact us. All right, and we'll move on to our second question here, which is, did you learn something new during today's event? And I hope so. This is a great kind of, it's an existing service, but one we're really trying to promote more and spread the word about because it is so applicable to so many different areas of the university. So we do hope you learned something new. If there's anything else you're interested in learning about visualization, do let us know. We're always happy to take feedback and make adjustments going forward, but it's great to see that everybody learned something new during today's event. All right, and our last poll question is, on a scale of 1 to 5, 5 being very satisfied, how would you rate today's event? And again, we always hope you're satisfied. If there's anything we can do to improve these events, do let us know. Personally, I love this one just because it had a lot of really interesting videos and visuals that we hope really illustrated what Matt and his team do, which I think is just a great example of the visualization services. So great, looks like everybody was quite pleased. And actually, we have one more question, and we're interested, if you're interested in learning more about visualization services, there's an option here. If you want to type your email address in, you can type it in here. We won't broadcast these so nobody else sees it. We can follow up with you after the event if you're interested in learning more, if you have a specific question, or if you're just wondering how to apply some of the data and information that you have in your area, and we can follow up with you directly after the presentation. So I'll give you all a moment to fill that in if you're interested in more information. And again, contact information is on the NUIT website if you want to think about it a little bit. And contact information, as I mentioned, is also available in the PowerPoint that we'll give you a chance to download in just a minute. Okay, and I'll give people one more moment to answer that. And if I switch screens and you're in the middle of typing your email address, you can also type it into the Q&A box at the bottom, and we'll collect those as well. All right, so I'm just about to switch the screen here. Okay. So to download the PowerPoint, again, it won't have all the nice visuals, the videos that Matt showed, but it will also have nice visuals and all the resources that Matt talked about. So just click this, and click download file, and it should open in a new browser window for you, and you can download that from there. And again, we'll also have it on the NUIT website later today or tomorrow, and you can view it that way. And great. Thank you so much, Matt. We appreciate your presentation.
Absolutely.
Have a great day, everyone.